question 1, explain the meaning of differentiation and what are the techniques of differentiation. The meaning of differentiation is the process of finding the rate of change of the slope of a curve at any point. So there are 4 techniques for differentiation. First is power rule. Power rule is the most common rule for function with a variable raised to a constant power. To differentiate x to the power of n, where n is any real number. The formula is d over dx in bracket x to the power of n equals to nx to the power of n minus 1. So from the formula, we bring the exponent down as a multiplier and reduce the exponent by minus 1. The second technique is product rule. Product rule used when differentiating a function that is the product of two separate functions, say u in bracket x and v in bracket x. The formula is fx equals to u times v, where the derivative of u times v is f prime x equals to u v prime plus v u prime. So the third technique is quotient rule. Quotient rule used when one function is divided by another, which is ux over vx. The formula is fx equals to u over v, where the derivative of u over v is f prime x equals to vu prime minus uv prime over v to the power of 2. So the last technique is chain rule. This is for composite function, a function within a function such as f in bracket gx, where the derivative of f in bracket gx is f prime in bracket gx times g prime. So we're gonna continue to question 2.
So for question 2a, find dy over dx for y equals to 3x squared sine 2x. So for the equation y equals to 3x squared sine 2x, we need to apply product rule to solve it. So for product rule, the formula is uv prime plus vu prime. So first of all, we have to find our u, v, u prime and v prime. So u is 3x squared. So how we get u prime is we have to differentiate u. So u is 3x squared. When we differentiate it, it becomes 6x. So for v is sine 2x. Then when we differentiate sine 2x, we get v prime. So v prime equals to 2 cos 2x. Why it becomes 2 cos 2x is because the angle inside of the sine, which is 2x, will not change. So it remains as 2x. Then the cos is the result of differentiating sine. So we get 2 cos 2x. So we apply the product rule and put it into the formula, which is dy over dx equals to uv prime plus vu prime. So 3x squared times 2 cos 2x and plus sine 2x times 6x. So we get 6x squared cos 2x plus 6x sine 2x. So to simplify this equation, we have to make the 6x alone at the outside and put x cos 2x plus sine 2x inside of the bracket. So that is for question A. So for question B, we need to solve y equals to sine in the bracket x cubed minus 2x squared plus 1 using chain rule. So the chain rule states that dy over dx is equals to dy over du times du over dx. So we first need to find u, du dx, y, and dy du. The u is the inner function of the equation, which is x cubed minus 2x squared plus 1. So we have to differentiate this equation. So we get du dx equals to 3x squared minus 4x. Then we have to differentiate y, which is the outer function, sine u. So when we differentiate sine u, we get dy du equals to cos u. So now we have to apply the chain rule. Then we substitute dy over du and du over dx into the formula, which is dy over dx equals to dy over du times du over dx. So we get cos u times 3x squared minus 4x. Then we substitute the u into the cos u. So it becomes cos in a bracket x cubed minus 2x squared plus 1. Then times 3x squared minus 4x. Then the final answer we get 3x squared minus 4x cos in the bracket x cubed minus 2x squared plus 1.
Let's solve question 3 together with me. Given e to the power of 2x plus 1 minus x squared tangent 2y plus ln xy equals to 0. Find dy dx using implicit differentiation. First and foremost, by applying derivative of standard function, differentiate e to the power of 2x plus 1, you will get e to the power of 2x plus 1 times differentiate of the power 2x plus 1, you will get 2e to the power of 2x plus 1. Next, for second term, we should differentiate negative x squared tangent 2y by using product rule. You will get u negative x squared, u prime negative 2x, v equals to tangent 2y, v prime equals to 2 secant squared 2y dy dx by applying implicit differentiation. By applying product rule, u v prime plus v prime, you will get negative x squared 2 secant squared 2y dy dx plus tangent 2y negative 2x. That equals to negative 2x squared secant squared 2y dy dx minus 2x tangent 2y. For the third and last term, you should differentiate ln xy. Ln xy is a multiplication ln x plus ln y, which equals to 1 over x plus 1 over y dy dx. Last step is by rearranging all three terms back to the question, which is 2e to the power of 2x plus 1 minus 2x squared secant squared 2y dy dx minus 2x tangent 2y plus 1 over x plus 1 over y dy dx equals to 0. Next, by rearranging the equation to y and x separately, whereby negative 2x squared secant squared 2y plus 1 over y equals to negative 2e to the power of 2x plus 1 plus 2x tangent 2y minus 1 over x. By differentiating the equation, you will get dy dx equals to negative 2e to the power of 2x plus 1 plus 2x tangent 2y minus 1 over x over negative 2x squared secant squared 2y plus 1 over y. All solved!
Okay, now let's move on with our last question, which is question 4. So for question 4, we need to use linear approximation to estimate the value of square root 15.98 over 3 minus with fourth root 15.98. So first thing first, we need to determine the value of x, x naught, and also delta x. We know that 15.98 is the x value. What is the nearest value with 15.98? It is 16, and we label 16 as x naught, which is estimate value. Now, for the change of x, which is delta x, we need to minus x with x naught, and we will get negative 0.02. Now, we need to find the fx function and also f prime x function. First, we need to replace 15.98 with x, and we will get 1 over 3 times x power of negative 1 over 2 minus x power of 1 over 4. For our f prime x, we get 1 over 8, 1 over 6 times of x power of negative 1 over 2 minus with 1 over 4 times x power of negative 3 over 4. Now, we need to substitute our f naught inside of fx and also f prime x. For f x naught, we substitute our x naught, which is 16, and we will get the negative 0.667. Now, for f prime x naught, same here, we need to substitute the 16 inside of our f prime x, and we will get 0.0104.
And the formula for linear approximation, we need to plus between f x node and f prime x node times delta x. And now we substitute our answer from our previous calculation, and we will get the final answer is negative 0.667. And that's all for question 4.